Hi students, let us come back to our physics class. Today we will solve some more problems on conservation laws. So yesterday, I have solved some problems on these chapters. Today also, so we will solve certain problems on this chapter. Okay. So these are formula so that already we have derived and in your previous session it is okay. So the problem is a 20-gram bullet moves at 10 meter per second in a horizontal directions, collides a 60-gram block, collides what is 60-gram block, move together with the same speed and the same directions. So what is the speed of both bullet and what is a block? Okay, so there is a problem. Uh, so here the mass of the bullet is 20 gram. So that's what convert into kg. That becomes what? Into 10 to the power minus 3. You can put it or it is 0.02 kg. Next, whereas the mass of the block, so it is 60 gram. So in terms of kg, it becomes what is 0.06 kg. Okay. Next, the initial speed of bullet. The initial speed of bullet is equals to how much is 10 meters per second. Next, the initial speed of block, which is at rest. The block is at what? Rest. That says what is 0. Okay. Next, the speed of bullet and blocks of the collisions. Those two things we want to what? And calculate. Okay. Here, this is inelastic collisions. So after colliding, so those two masses sticks together are coalesces into a single mass and move with the one velocity. So here, the collision is elastic. That's why mp vp plus of what? mv vb that's equals to mp plus of what? mv into what? V dash. Where? So v dash is the what? The final velocity of those two particles. Okay. So the mass of the bullet is 0.02 and which is moving with a velocity of 10 plus the mass of that even what? A block is 0.06 kg. It is in rest. That's why it is 0. So mp plus mv is 0.2, 0.6, 0.06 into you write what? A v dash. So after doing all the simple manipulations, so you will get what? 0.2 equals to 0.08 V dash. Therefore, V dash is equals to what is 0.2 divided by what? 0.08. So that will give you the what? The final velocity of your both bullet and block becomes how much it is. They together move the velocity of how much it is 2.5 meter per second. Okay. So this is here that initial velocities after your bullet is 10 meter per second is there. The final velocity becomes what is 2.5. That's why in case of the inelastic collision, the kinetic energy what is not conserved. Okay, this is one simple problem on your elastic purpose. Next, another one is two objects, let us say A and B, have the same mass 1.5 kg, approach each other and collide. Speed of object A is that how much is 4 meter per second, whereas the speed of your object is 5 meter per second. If the collision is inelastic, what is the speed of the what? Both objects after collision are again the same thing. Okay. MA, the mass of the object A is 1.5 kg as well as what? Mass of the object B is also 1.5 kg. The speed the speed of your object A before collision is 4 meter per second. That is also in positive directions. Whereas that your what? B is what is which is approaching towards your A. So this one is taken as what? Minus 5 meter per second. This is in what? Negative direction. Okay. So now you write the equations, your law of conservation of linear momentum. MA plus MA into VA Thrust of mv into vb equals to what? Na plus mb. So that bracket into what is v dash. Again, v dash is what is the final velocity of your object a and b. Here, v of a and v of b are the what? Initial velocity of your object a and b is. Okay. So now you want to insert the values. So 1.5 into 4 plus 1.5 into minus 5. So that's equals to 1.5 plus 1.5 into what? V dash. Okay. So therefore, it becomes 6 minus of 7.5. That's equals to what? 3 into V dash. So minus of 1.5 equals to 3. Therefore, V dash is equal to how much is? Minus of 1.5 divided by 3. So the final velocity of the your what? Goes to objects A and B is how much is? Minus 0.5 meter per second. But minus sign in this case indicates that after collisions, both objects move leftward, same directions as the what? Object is what is updates. So this is the meaning of the what? Negative sign. Okay. So next we take another example, simple examples. A force of 120 Newton is applied perpendicular on a even what? A spanner at a distance of how much it is? 9 centimeters from a net. The torque produced by the force will be how much? So we know that the torque is nothing but what? R into its what? Yeah. So here the force which is acting on that spanner is 120 Newton. That causes a distance of how much is 9 centimeters. So therefore, the formula is the torque is equals to what is that formula? 2 is equals to R into F. So R is 9 and F is what? 120. So 120 into 9 becomes as what? So this one, so you want to convert the distance into in terms of what? Meter. So there you will get what? 9 into 10 to minus 2. So that's why it becomes how much is answer? 10.8 Newton meters. Like that. So you have to calculate the problem on a torque. Okay. Next, so another example is the string of car has a radius of how much it is? 15 centimeter. The torque produced by a couple of what? 10 Newton will be what? So again, you want to calculate. So what is the torque you produce in that your string of car? Okay. The R is 15 centimeter. The force is how much is 10 Newton. So again, the torque is equal to 40 into 15. 40 into what? 15. So that will give you the how much it is? 6 Newton a meter. That will give us what? 6 Newton meter. So you write what? 40 into 15. So into 10 to the minus 3. Okay. That will give us what? 6 Newton. 6 Newton meters. So like this. So you have to what? Solve the problems on what is your topics. Okay. Next, let's discuss another some more problems on your what uh, conservation laws. So see here, first one is a block is displaced. What is a block is displaced by 3 meter when a force of 120 Newton. When a what? A force of 120 Newton. So it's not 120, it's 200 Newton is applied on it. 200 Newton is what? Applied on it on an inclined surface which is at an angle of how much is 50 degree with the horizontal. What is the work done? So what is the work done? So we know that the work done by the force on an object, if the applied force makes in what? But then an angle with the displacement in the direction of what? Displacement. Then in such cases, so we know the formula W is equal to what? F S into cos. Okay. So here the force of Newton is how much it is? 200 Newton into like what? 200 into what? 3. So that distance is what? 3. 200 into 3 into cost of what is up 50. So that will give you the value of your what amount of work has done on that your object due to the applications of what is forces. Okay, force is 200 Newton, the displacement is 3, and into what cost of 50 degrees. So that will give you the what the value of what the amount of work done by the force on an what is object. Okay, so again, so let's see another example. If a particle of mass 5 kg moves uniformly along a circle of radius 10 meter at what is 10 meter per second, then what is the work done by a centripetal force during its what? One revolution. So that was what I calculated. So see here, if a particle of mass 5 kg moves uniformly along a circle, along a what? Circle of radius, how much it is? 10 meter at what it is speed of how much is 10 meter per second, then what is the work done by what is the centripetal force during one revolution. So the centripetal force is the force which is what always directly towards the center of circular part. Here also you have to calculate what then what is the work done by the centripetal force that you have to calculate. F is equals to you know that here we know the formula. F is equals to what is W into, sorry, W equals to what? Force into displacement. Here force is not given. The force is equals to, you want to calculate here. You want to calculate what? F. F is equals to what? M into A. Here M is not given. M is there, 5 kg, and the velocity is what is 10 meter per second is there. So on knowing these values during one revolutions, uh, that's your angular velocity. After calculating that A, so you will get what? F. Then you want to substitute the value of what? F is. So on knowing that F, so you are getting what? F is equals to what? Force into displacement as 10 meter is there. So you will get what? So what amount of work is done in what it is? One revolution is. Okay. Next, a crate of mass 50 kg is pushed along a floor with a force of how much is 20 Newton for a distance of how much is 5 meter. Calculate the work done. So here, what is a crate of mass 50 kg is pushed along a floor with a force of 20 Newton for a distance of how much is 5 meter. So calculate the work done. So we know that force, that's work done is equal to what? Force into displacement. Okay. So here, the Newton is the force into displacement. Force is 20 Newton into the displacement is how much it is. So that displacement object now is 5 meter. Okay. So 5 meters. That this work done is equal to what? 100 Newton meter. But the energy transformed is equal to what? Work done. The energy is measured in joule. So the Newton meter must be the same unit as what? J. This means we can say that work done is equal to 100 Newton. Whatever that calculated in the above things, this is what same. This is the interpretation of what that that value is. Okay. Next, let us see here. How another one? How far must a 5 Newton force pull a 50 kg, 50 grams car if 30 joule of energies are what? Transferred. We know that work done is equals to what? Force into displacement. Let us rearrange these equations. So here he is asked to calculate what? How far when a 5 Newton force pull a what? 50-gram car of 30 joule of energies are what? Transformed. That means you have to calculate what? So how much distance that toy of car has moved when so you have applied what 5 Newton of force on that object. Okay. So therefore, D is equals to work done divided by and F. So here the work done is how much is 30 joule of energy is what? Applied. So divided by, you are getting more is the force applied on that object is how much is 5 newtons. So therefore, the distance moved by the river what is uh, a toy of car is what? 6 meters. Okay. So there is another example on what? What? So see here one more simple example on that your conversion laws is a football of mass 2.5 kg is lifted up to what? The top of a cliff that is 180-meter high. How much potential energy does the football gain? So here, the football is weighing how much is 2.5 kg when is it lifted? So that's to a height of how much is 180 meters and what is the potential energy produced by that football. So that we know that potential energy at that particular point, Ut is equal to mg into what? H. So m is 2.5, the acceleration due to gravity. So here is taken over 10, 9.8. So approximately it is taken over 10, 2.5 into 10 into what? 180. So that will give you what? So 4,500 joule of energy what possessed by the what? Okay. Next on your power, a person of mass 70 kg runs up a what? Flight of stairs with a vertical height of what? 5 meters. If the trip takes 7 seconds, 7 seconds to calculate the person's power. So here the work done is equals to what? The potential energy of produced by that person. Okay. So work done is equals to EP, that's is equals to what? M into G H. So here M is the mass of that person is 70 and the acceleration due to gravity is 10 and the height. So he has to move with the vertical height is how much is 5. So therefore the power possessed by that person is 3,500 joules. Next, this is what? This is what? Now you want to calculate the power. So power is equal to work done divided by what is at times. Therefore, 3,500 divided by 7, so that will give you what? 500 watts. This is the what? The power of or what? Person. Okay. So with this entire chapter is what? Completed. Thank you.